My dear friends, we have already started. We had started the transformer, but the person who is doing the artworking for me for the figures is little busy. So I had to leave transformer at third session. There may be around 10 sessions of transformer, but meanwhile, this transmission line was ready. So I'm continuing with that. In that, I've already taken 2 sessions. In the first session, we have seen a simple, a very primitive radial feeder production. When I say primitive, it does not mean that it does not exist. It does exist. 66 kV system goes to 11 kV system. 11 kV system goes to 415 volt. That is a radial system. Therefore, it is applicable. Also, for higher voltages as a backup, overcurrent and earth fault relays are used. Therefore, we have to study them. In the second session, we were trying to see how the relay will discriminate between fault locations, how the relay will come to know where the fault is. If it is 100-kilometer long line, followed by that there is another 70-kilometer long line, followed by that there is another 40-kilometer long line. So how will the relay discriminate between these locations? That is the biggest problem. That is the biggest problem. So to solve that problem, we have started with current discrimination, because we know that as we go away from the source, the impedance goes on increasing, and as current is equal to E upon Z, Z increasing means current will decrease. Therefore, current can be used as a discriminating quantity. But then we saw that there are about 6 to 7 problems, and therefore instantaneous overcurrent relay alone cannot be used. No doubt, it can be used as an ancillary feature, as an auxiliary feature, as an assisting feature. That we will keep on seeing in the slides to come. So in this section, we are trying to see another kind of discriminating quantity. If current fails, then now I am taking time as a discriminating quantity. You see, so rather than reading this, I'll go to the I'll go to the figure, and figure will explain everything. You can read the explanation afterwards. What all I'm explaining is written there. Now, same radial feeder I got R1, R2, R3, AB, BC, CD, R3 feeders. Not necessarily there can be 4, there can be 5, but here I have taken 3. And transformers are there, but for the sake of simplicity, I have removed. Now, what my requirement is, if there is a fault in CD, R2 has to sense. The problem with instantaneous overcurrent relay was that R2 was not sensing the fault in line CD. Here, R2 has to sense, because if R3 fails, R2 has to give backup. So first thing is, when there is a fault in line CD, R2 also senses and R3 also senses. Now which will operate? R3 only has to operate. If R2 operates, it is wrong. So that is something you have to do for that. Similarly, if there's a line in section BC, the line BC will operate and AB will give backup. That is really R1 will give backup. This is what I want. So what I am doing, I am setting the time of operation of R3, the list, maybe 0.1 second or something, right? And R2, I set little more time. Now, little more time means there is also a technicality which we will talk later, but the discrimination margin of 0.25 second is used. Therefore, R2 will operate after 0.35, R3 after 0.1, R2 after 0.35, and R1 after 0.6 seconds. So now you see, you think of all disadvantages of instantaneous overcurrent relays are gone. In instantaneous overcurrent relays, we were not taking care of thermal capability. Here, you are taking time in tripping. Therefore, you are exploiting the thermal capability of the equipment. You are taking care of the instability of the generator, right? Backup it is giving. R2 is giving backup to R3 because R2 has to reach up to D. Similarly, transient overreach problem is not there because by the time the relay operates, transient is gone and steady state is existing. Therefore, that problem is gone. And type of fault. You see, what do? We make R2 to reach. That means R2 will operate if there is a fault on bus D. Now try to understand me. Right now I am talking for phase relays. I am not talking for ground relays. Ground relay means the fault in which ground is concerned, LG and LLG. Right now we are talking about LL and LLL. Now the problem is the fault current for LLL is more than LL. Fault current LL is about 86% of LLL. You learned that in your theory classes in BTech. Problem is that we are forgetting what we have learned in BTech. One of my students who passed in 1990 after 32 years, he got promoted. I don't know his salary because I asked because he cannot disclose his salary. Therefore, he did not tell his salary, but he must be earning quite a good amount. He told that he is taking 5 interviews of BTech students every year, every week. So to one of the students, he showed that single phase, that ceiling fan at the top in his cabin. And he asked that BTech student, my friends here, he asked that BTech student whether this fan is single phase or 3-phase. The fellow told, I don't know. Fellow told, if I would have been PM Modi, if I would have been Prime Minister, I would throw him to first standard. I am Brahmin and Parshuram, परसू लेके घूमता हूं लोगों के धड़ माथे निकाल दूंगा मैं. I dislike a student who is BTech does not know that ceiling fan is a single phase fan. One of the students could say that it is single phase. So the another question that single phase cannot start of his own. So what do? Then he told he does not know. This is what our BTech in all India, probably in all world, this is what we are learning in BTech. This is what we are learning in BTech. And therefore, I know that whatever I am telling in these videos is too difficult for you to understand. Many industrialists who have experience of 30 years may understand. But no student can understand this because this is too difficult what I am telling. And you are habituated with very easy things. You want that in your final exam 2 plus 2 is equal to 4 is asked. I was telling in PDPU I am serving in second internal test, the 30 marks paper was there, the average was 7. So the head of the department told me that in final paper you will be little lenient. I told okay. And I told the students also after that in the class that head of the department has told me to be lenient. So I'm going to set a paper like this. Say question 2 plus 2. Multiple choice question 2 plus 2. Choice A 4. Choice B 5. Choice C 7. And choice D 12. Now I think this is too simple. But I told you I can make it yet simpler. 2 plus 2 is the same. Choice A is 4. Choice B is table. Choice C is chair. And choice D is donkey. Come on. Get 100% marks. My dear honorable engineers, particularly students if they are hearing me, I am very much annoyed against such students. And therefore, from next semester, I am leaving Nirma and PDPU. Nirma and PDPU are class 1 institutes. These students are also this bad. I asked them 2 into 2. So first they calculator table पर तो रखते नहीं. They take out calculator from the uh, that their laptop box and then take out the calculator. Then 2 plus 2, sir, 4. These are our students. So my dear friends, this is power system protection is a very logical subject. You are sound at logic, then you will understand. Here. So transient overreach problem is not there. And when I'm making B to reach up to D, that is I'm making relay R2 to reach up to D for least fault, double line fault. So for triple line fault, it will certainly reach because it is more. And that also I make R2 to reach up to D for minimum generation because I have shown here only one generator. There is no one generator. There are 5, 6, 7 generators. So at night time when less number of generators are working, then also R2 should give backup to R3. That is how I am doing. So all problems of instantaneous overcurrent relays are solved. But then, my dear friends, the problem is if you can appreciate the problem, a very big problem has occurred. In the first zone AB, which has the fault, if fault occurs in AB, it is the worst fault because it is very near to the generator. The time taken is 0.6 seconds. And within that, there can be very bad damage. So what can you do? 80% of the line as shown by hashed line, you protect by instantaneous overcurrent relay. So that way you are saving some time. You are reducing the damage. But what about remnant 20%? Because you cannot make instantaneous overcurrent relay to reach up to full section. So that problem yet remains, right? And another thing, if the line is too short, this is the problem of ZS by ZL ratio. So it is not only the problem for last section, it can be a problem for first section also. Say Ukai hydro to Ukai thermal is 6 kilometer line. There you cannot use instantaneous overcurrent relay because 6 kilometer cannot be an accuracy of instantaneous overcurrent relay. So that is the reason why time discrimination, which we have started talking about, is useless. This can also not be used for transmission line protection. So then what can be used? So what can be used? This is all what I've told. So I'm just skipping. I am to use current time discrimination. Current and time both. I will use IDMT over current relays because what is my requirement? If the fault current is large, it should be cleared fast because damage is bad. And if the fault current is small, it should be cleared slowly. Try to understand, it should be cleared slowly. That is very important requirement because the equipment are capable to carry that fault current. So you should give a chance to equipment to withstand its fault current capability. So you should, if the equipment is going to be damaged after 15 seconds, you should not trip before 12 or 13 seconds. So further the fault, more the time. Nearer the fault, less the time. Exactly inverse. Time of operation of the relay is inversely proportional to overcurrent. I mean inversely proportional to the distance. R1, R2, R3 are now IDMT relays. Inverse definite minimum time. That definite minimum time is a feature required. Time does not permit me to, because I will have to calculate the example to show you that you will not be able to set pure inverse relay. Pure inverse relay means IT equal to K. IT equal to K means the rectangular hyperbola that cannot be used. So what I do after PSM 20, I hope you know PSM. PSM is plug setting multiplier. fault current upon plug setting, that is plug setting multiplier. After PSM 20, the time of the operation of relay is definite. So I am using definite time over current relay there. It does not vary then. But up to 20, it follows the inverse curve. It follows the inverse curve. So this is the diagram. Same R1, R2, R3, same feeder. I'm not changing the feeder. But you can see that definite time and inverse, what time I am saving. That is shown by hashed line. And also, you can attach an instantaneous overcurrent unit number 1. So you can make the nearer faults to be tripped faster. All these things are possible. And therefore, IDMT overcurrent relays are the best, and therefore they are used in practice. So we will be using this in practice. Yes. So when we are going to use this in practice, we have to learn these things in detail. We have to learn these things in detail. So phase relays. Phase relays are meant for sensing triple line or double line faults. That is faults not involving ground. So we are not talking about the ground relays now. We will talk afterwards. So what are the rules for phase relays? For plug setting. What is plug setting? Plug setting is a threshold beyond which the relay will start operating. Right. So the first rule is plug setting must not be less than the maximum load current. Because you see, load current is not constant. There is a load curve. It goes on varying. At certain times, say at evening time, the current is maximum. So for that current, relay must not trip. Not only that, but I have to allow for 10% overload also. Because up to 10% overload, no equipment is damaged. Therefore, you see, considering all this, I have to decide the plug setting. I cannot decide the plug setting less than that. Otherwise, there will be uncalled for tripping. That is very logical. I mean, that is nothing is required to be rather explained. But the second rule is little difficult. That when I say that plug setting is a threshold, I tell to the students that what is the meaning of threshold. So this video is going to the all corners of the world, right? It will go to Gujarat also. But probably Gujarat students may also not be able to understand. Only Kathiawadi students can understand. The Gujarati equivalent of threshold is at the plug setting, relay neither operates nor not operates. So in Gujarati we call it relay operate thau thau thai pan thai nahi. Thau thau thai. Now I'm sorry, all other countries will not be able to understand, but threshold. But then when you say threshold, it does not operate at that point. Then at what point it operates? Say I have set at 1 ampere. So at 2 ampere it will certainly operate. 3 ampere it will certainly operate. It's not so. I have to decide something. So IS has decided that relay must start operating from 1.05 to 1.3 times the plug setting. And while deciding the relay setting, you have to take this into consideration. For this, I have given this figure. You check up. Simple figure, no other feeders. No other feeders. From A, B, C, other feeders are not going. Just assume all CTs are 500 bar 1. And my current CD is 400 ampere. So 400 divided by 500 into 100 gives me 80%. And because 80% is not available, our relays are 50 to 100% in 7 equal steps. I'm talking about electromagnetic relays. In static relays, you can set in numerical relays, you can set 80%. But let us keep numerical relay aside now. We set at 100%. Through R2 also same current is passing. So that also should be 100%. And R1 also same current is passing. But if I set R1, R2, R3 at 100%, I will be wrong. Why I will be wrong? I'll be wrong because beyond D there is a distribution line. In distribution line, far away there is some fault on 415-volt feeder, or there is some overload, right? Due to which the current equal to 600 ampere passes. 600 ampere passes. Now you are allowing 1.05 to 1.3 because you see it has to be allowed. No relay manufacturer can manufacture exact. Therefore, it is quite possible that R2 picks up at 1.05 times its setting. I have kept 100%. So 1.05 means 105. Right? Sorry, 1.05 is 105. But if I talk in terms of primary 500, it is 525. My fault current is 600. So relay R2 will operate because it is 525. 600 is more than 525. But R3 picks up at 1.3. So 1.3 into 500 is 650. So fault current is 600. R3 does not pick up. I have kept the time of operation of R3 less than R2. Howsoever, but R3 does not start. Therefore, R2 operates and R3 does not operate. That is wrong according to the philosophy of protection. Only nearest relay should operate, and therefore plug setting of R2 should be higher. The rule is the pickup of R2 should be higher than pickup of R3. Other way around, you see 1.05 times flux. You may say that it is 1.3 times and the other one is 1.05 times. Okay, then well and good. I am not worried. But this is the worst. 1.05 times flux setting of R2 should be higher than 1.3 times flux setting of R3. So plug setting of R2 is more than 1.3 divided by 1.05 of plug setting of R3. This is the mathematical expression of this rule. Now you have selected the plug setting according to rated current also. You are selecting the plug setting according to this formula also. Whichever is higher is your plug setting. Whichever is higher is your plug setting. That is the second rule. That is the second rule. Third rule, very important. R2 should reach up to D for double line fault with minimum generation. Now it may so happen that if the fault current at D is so low that you have to set R2 at lower value. But when you set at lower value, then it is more than the rated. I mean, that lower value, you will have to set R2 at lower value, right? Means say at current, double line current at D is small, then R2 you will have to set at lower value. If you set at lower value, then it will operate for lower value and it will not allow the rated current to pass through. So in this case, you have to use voltage controlled overcurrent relays. Probably in the next slides, we will see the voltage controlled overcurrent relays. Right now, we agree that with these two rules, R2 will reach up to D. So we assume that, right? So rule 3 we ignore for the time being. So this completes our presentation. We are using IDMT relays for 66 kV, 11 kV, 6.6 kV, 3.3 kV lines. Only as a primary relay for 132 kV, 220 kV, 400 kV, we use overcurrent relay, but as a backup to distance or as a backup to line differential. So please stay tuned with Head Up Me. I have learned that my viewers are touching 1,000 1000 is too small a figure. It has to touch 4000. And for touching 4000, I cannot do anything from my mobile. I can do it only once. From your mobile, you have to view the whole video. I have seen that so often my friends are doing that. Oh, this is Oza sir's video. We must like. So without seeing the video, they like. So that does not help me. They should read, even though they know. I know that I've taught them, so they know everything. Probably some students are at such positions that they know better than me. But as a Guru Dakshina, समझो आपको मुझको गुरु दक्षिणा देनी है मेरे स्टूडेंट्स को. So my students, as a part of Guru Dakshina, they should read this half an hour lecture so that my viewers increase. And those who are not knowing me, they can certainly read. They can certainly hear. If they find that it is useless, I don't mind. But if they find that it is useful, and I'm getting. Yesterday, I talked with for about half an hour with one person in Ghana. He is doing MTech and he wants he's doing the project work. He wants the the project titles from power system protection because he likes power system protection. I am not a researcher. I am not at all a researcher. I consider myself a consultant, but yet I gave him some 9-10 topics. There can be a problem of language because Ghana and India. So he told that, sir, the voice is cutting also. So you send me a voice message. I sent him a voice message for about half an hour, and I am not charged for that. I am not charging for this also. This is free of cost. But then the name of Adopt should be known to every electrical engineer in the world. That is what I want from you all. And if you consider me Guru, there is no equivalent to Guru. People say master. Teacher is not Guru. Teacher is teaching. Guru is taking complete care of a disciple, of a student. So if you consider me Guru, if you consider me master, please give me Guru Dakshina in terms of liking the video, in terms of subscribing the Adopt Me channel, and in terms of hearing the complete video. You see, 4,000 viewers is nothing. If 8,000 people here, this is a half an hour video. If 8,000 electrical engineers here, then it will be 4,000. 8,000 have yet not heard fully. Therefore, it is not happening. So friends, anyway, you have heard me patiently. Thank you so much and good day.